First thing you do is find out how many are bad. I usually draw a picture because it kind of helps me to draw a picture. Bring it down a little bit, Sam. All the way. Get all the way down. All right. So we've got 559 CDs in a crate. And by past statistics, they calculate that 244 are effective. So 244 are no good. If 244 are no good, how many are good? 315 are good. So that takes care of this and that. It says with one method of procedure called accepted sampling, a sample of items randomly selected without replacement, and the entire batch is accepted if every item in the sample is what? Is okay. So we're going to pick 3 CDs out of this 559. And we want to know what is the probability of all 3 being good. So we're going to use the 315 group. So that's going to be 315 over 559 times 314 out of 558 times 313 out of 557. Now take your handy dandy calculator. Don't forget to use your parentheses. And it'd be parentheses 315 out of 559 close parentheses times 314 out of 557 558 close parentheses times parentheses 313 over 557 close parentheses. Now when you do that, you get 1782, right? So that gives us 1782. Now let's see if there's a difference if we did it with replacement. Probably be just a little bit of difference on that last digit because the numbers aren't as high as we would like them. So that'd be 315 over 559 raised to the what? Third power. Somebody give me that to 5 digits. 0.17893. So there's a little bit of difference. I knew there'd be a little bit of a difference there. But usually they want you to go to 3 digits. So there'll be a little bit of difference. Now, there's also, let me show you this in the question. I'm going to type in the wrong answer for a reason. They usually give tolerance there. The reason I was showing you the reason I put in the wrong answer is so it would do this. Usually they put a tolerance in there of 0.001 plus or minus, but I don't see it though in this one. So they get the answer as 0.179. I don't know how they get the tolerance as 0.179 with that one though. Yeah, but they didn't. They did without replacement. This is with replacement. See, without replacement is this one right here. So they usually, what they usually have, they say the correct answer is 0.1779, and they used to have plus or minus 0.0001 or something like that. So oh well. Does this result suggest that the entire batch consists of good CDs? Why or why not? Well, is this probability high? I mean, 18%, you got an 18% chance of getting all 3 CDs. Good. Is that a high probability? I don't think it is, but I don't know how to answer these questions because they word them like a Philadelphia lawyer. So it says, does the result in A, this is A, I guess, suggest that the entire batch is no. That would be my answer right there. Because that would be the only way that you would know that the CDs are good, is you get a probability of 1. So I don't really care about that. I care about this. I want to do that one again. Alright, try that one. Got a little bit higher numbers on this one. Blow it up a little bit, Banner, so people can see it, please. 1136 and 288 are defective. That wasn't my video camera. Okay. No, we're going to do it together. I'm going to do it on the board. Okay, now that one came out better. 0.416 is your answer, and you get it either way. Those of you that want to look, there's my calculations. If you did it with replacement, you get 0.41596. If you did it without replacement, you get 0.41558. But it always rounds to the third digit, so that would be 0.416 and 0.416. That last one, I don't understand why it didn't come out the same. Now, 41% chance, it's a little better, or 42% chance, but let's see what it says. That would be A again. So unless you get one there, that's going to be your answer. Find another. That's a test question. The O and the A, the positive, that's a test question. In the market research survey of 2,913 motorists, 200 said that they made an obscene gesture in the previous month. Let's all guess what that obscene gesture was. Completes part A and B. If one of the surveyed motorists is randomly selected, what is the probability that this motorist did not make an obscene gesture in the previous month? Try that one. What is did not make an obscene gesture? What is that called? Compliment. Good. Now you can find this two different ways. What's one way of finding it? Break it down, Devin, please. One more time. Read it all the way down. Okay. What's one way of finding it? Okay. Say 2913 minus 200 over what? 2913. And somebody tell me what you get when you subtract 200 from it. 2713 over 2913, and somebody give me that decimal. Okay, what's the other way of doing it? And subtract it from 1. 200 over 2913 and subtract it from 1. And that's going to be 1 minus 0.931. Or let's see, no, that would that be? No, that would be the answer. 42.169. Is that what it came out to be? Somebody take 200 and divide it by 2913. What do you get? Get 0.169. Yes, or 0.069. 0.069. And that equals 0.9. So that's two different ways you can get it. By using, by using the complement before you start the problem, or using the complement after the problem. In other words, 1 minus and just take away the 200. So however you want to do it. You still get the same answer. What's the 4th decimal place? Somebody tell me, I didn't. What is it? It says round to 4. 0.93 what? I'm sorry, what? 0.9313. Good job. Now, it says if 50 of the surveyed motorists are randomly selected without replacement. Without replacement. Usually when you're talking about bodies, without replacement. 50 of the surveyed motorists are randomly selected without replacement. What is the probability that none of them made an obscene gesture in the previous month? Should the 5% guideline be applied in this case? Select the correct choice, blah, blah, blah. We'll just do the math. Don't worry about the 5% guideline. Let's just do the math. If 50 of the surveyed motorists are randomly selected without replacement, what is the probability that none of them made an obscene gesture? In other words, they did not make an obscene gesture. So the ones that did not make an obscene gesture was 2713, right? Yes, no, maybe. So that'd be 2713 over 2913 raised to the what? 50th power? Am I reading that correctly? Now, I'm not going to do 50 calculations. That's ridiculous. That's the way I'm reading the question. Huh? Yeah, but you're talking about 4 digits. So, I'm not going to do 50. Y'all going to do it 50 times? I'm not. Y'all go knock yourself out. I'm not going to do it. But I think that's the way I'm reading the question. So I'm going to take 27, 13, oops, sorry. 27, 13 divided by 29, 13 and raise it to the 50th power. 0.0285. What does it say round it to? 4.0285. I guess it should not be applied. 0.0285. I don't understand what the I don't understand what the 5%, 0.0285, must be something the book puts in. I have to read about that. I don't think there's a difference between the two, but I'm not going to do, I don't think the book wants you to do 50. You would have to do what? 27, I done lost my train of thought. 2713 over 2913 times 2712 over 2912. But you'd have to times that 50 times. I'm not going to do that. Alright, let's look at this one. The data in the table below summarizes results from 143 pedestrian deaths that were caused by accidents. If two different deaths are randomly selected without replacement, we're talking about bodies without replacement, find the probability that they both involved intoxicated drivers. Okay? So the data in the table below summarizes 143. Can you imagine a pedestrian being intoxicated and the driver being intoxicated? That'd be a high probability. Oh me. If two different deaths are randomly selected, in other words, they put all these deaths in a hat without replacement, find the probability that they both involved intoxicated drivers. So intoxicated drivers, driver intoxicated, yes. So what's the total? 143? Add them up and see. Should be 143. $80 plus 20. Let's see, 20. There's 23 right there, so 24. So 80 plus 20 is 100, and that'd be 100 and what? 6. 106 plus 37. Yeah, that'd be close to 143, wouldn't it? So, 2 deaths. What's the 13 plus 37? Dang old 50. So that's going to be 50 over 143 times 49 over times 49 over what? 142. Well, that's a test question. I like the test questions that don't ask you a bunch of stupid questions. I just want the math. So put your handy dandy calculator out, and dang old parentheses 50 divided by 143, dang old close parentheses, times 49 divided by 142, and that should be your answer. So if you put all these people's names in a hat, and you put beside their name if they were intoxicated as a driver or intoxicated as a pedestrian or not intoxicated, blah 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 blah. If you was to just pull out, what is the probability of just pulling out the driver was intoxicated? You're talking about a 12% chance or a 0.12 probability. Round 3 decimal places. Dang old, forgot what it was. 0.121. And you feel good about yourself. No. Is such an event unlikely? 0.12. Well, less. It's not less. It's greater than 5%. So it's either this one or it's this one. I would say yes, because it's greater than 5%. See? No, because it is greater than 5%. Now see, I know where they're getting that 5% from. They're getting it from here. So let's look at it. 5% they're talking about is where? Right there, correct? Now, if it's greater than 5%, that means it falls in here. And that means what? What is this right here called? Normal, right? So, is such an event unlikely? Unlikely would be unusual. So, no, it would not be unusual, because where does it fall? It falls in. So you gotta, these questions you have to think about, and sometimes it's better to draw a picture, because if I'd have drawn this picture and change this word to what? Unusual. If you think of it as unusual, then you look at this and you know, let me explain this. This right here, according to your empirical rule, what's the green area? Normal or usual? If you want to call it usual. The yellow is unusual. The yellow is 5%. What is 12%? It's greater than 5%. So it jumps out of the yellow into the green, so it's normal or usual. So is such an event unusual? No, because the probability is greater than 0.05. It always helps to draw that. I should have done that on the last one. I suck. Alright, right quick, let's go back and do an additive rule right quick, just so everybody's got it in check. And then we'll move on to the factorials. And I'll try to confuse you on those, so you can fail the test. Good deal? Another driver intoxicated and pedestrian intoxicated. I'm sorry, I just laugh about that when I think about it. All right, did we do this one? Y'all remember doing this one? Okay, nobody's gonna talk to me. The following data summarizes results from 939 pedestrian deaths that were caused by accidents. If one of the pedestrian deaths is randomly selected, find the probability that the pedestrian was intoxicated or the driver was intoxicated. Okay? So, the pedestrian was intoxicated and the driver was intoxicated. Alright? Blow it up a little bit, Dan, so everybody can see the numbers, please. So the total is what? 939, so that's on the bottom. And the green is going to be 82 plus 219 plus the yellow, and I know you're not going to be able to see the yellow too good, but just work with me. 82 plus 81 oops. And what are we going to do? Subtract the what? Subtract the overlap, and I'll take my handy dandy red highlighter. We'll use magenta. How about that? Ooh. Kind of takes out the 82, don't it? And that's going to be the 82. And that should be your answer. So let's pull up our handy dandy virtual calculator that we carry around in our pocket. Where'd it go? Dadgummit. Bush's fault. So 82 plus 219 plus 82 plus 81 minus 81 equals, what'd I say? Alright. Where'd I get the 81? Oh, I can't read my own writing. Minus 1. How about that? Is that better? Divided by 939. Dang old 4068. Dang old 407. Is that what y'all got? And we feel good about ourselves. So we don't wear sunglasses in the building. Did we go over the roulette table? Yes or no? Let's go over the roulette table because that is a test question. But one of the days we had a bad computer day, didn't we? Which is about every day, thanks to our Phantom. Let's see if I can find it for you. I looked for it one day, and that is a test question because I don't put pothead questions on. I try not to. I don't like potheads. We used to knock them down in the dark hall at West Side. And y'all know where the dark hall is at West Side? That's where they used to hang out. We used to knock them down after lunch. Alright, there you go. Now this is a test question for one reason, and that's because, blow it up a little bit down here, of the odd and not odd, even and not even. That's fine. A modified roulette wheel has 32 slots. One slot is 0, the other is double 0, and the others are numbered 1 through 30. You are placing a bet that the outcome is an even number. But on the roulette table, 0 and double 0 are neither odd or even. So that kind of throws a twist in it. So go ahead and try it. And then they're going to ask you something else. They're going to ask you the odds against winning. Then they're going to ask you for a bet. So we'll take it step by step. Go ahead and find the probability right now. Somebody tell me what the success is in this problem. What is success? Winning. But how do you win? Even number. So an even number, the probability of an even number is going to be your success. And in odds against, it's odds against the probability of failure over the probability of success. Do not change this to a decimal because it makes the math harder if you change it to a decimal. Leave it as a fraction on this problem. We didn't go over one of these either. There was something going on that day and I couldn't find it, or something's wrong with the computer or something. Glad I remembered to go over it. Freeze it right quick, Dana, please. Still waiting. There you go, Vanna. Dang, I'll pull up a roulette table for y'all. So you, that's some of y'all. Roulette table. Roulette. Oh, things I have to do for y'all. Because I know there's somebody out there going, what is a roulette table? I don't even know how to spell it. Dang, I must have got it right. Alright, now unfreeze it. There's a dang old roulette wheel. Now, how does it work?
You fill a little ball into it and put it in one of those slots.
You spin one way and you spin the ball, the marble, the other way. One goes counterclockwise and then the marble falls, you put it out here and it goes on the wooden part, and then eventually it hits one of these bumpers and slows down, and then it falls into one of these numbers right here. And this one don't have, I don't see a 0 and a 00 on this one, but on the table there, that one's got 0. There was one while ago that had 00 right there. I was going to find the one that had the whole thing. Well, there it is. There's one that has 0 and 00 right there. So 0, there's 0 and 00's over here. So that's a roulette table. Okay, so everybody good? Everybody knows what a roulette table is now. Now I'm teaching y'all how to gamble. Somebody else needs to teach us how to gamble. What else is new? Alright, so we got a roulette wheel. It's all the way down there. Almost. One more time. There we go. Alright. The roulette wheel has 32 slots. Success, probability of an even number, that's our success, is going to be, what's half of 30? 15 over 32. The probability of not even, and that's failure, is going to be what? 17 over 32. Because what is not even? It's all the odd numbers here, but what? These two right here. Remember, how many slots are there on the wheel? There's 32. So you've got to, this number and this number have to add up to what? 32. Remember that. And that's where people get the question wrong. Now, leave this in fraction form, because you just found out the probability of winning is 15 over 32. So you would type in 15 over 32 right here. The second part of the question is going to ask you for the odds against. What's the odds against winning? So that would be the probability of failure over the probability of what? Success. So the odds against is equal to the probability of failure over the probability of success. And what do you do when you divide by a fraction? Multiply by the reciprocal, Hubert. Thank you, class. And what happens to the 32s? They cancel. That's why you need to leave it as a fraction. And your answer is 17 to what? 17 to 15. Now this is one of those questions that I ask students that have been in probability before, and most of them can't answer the question. What does that mean, 17 to 15? What does that mean? Well, I'm going to give you a quick example right quick, and hopefully you won't forget it. We're going to take a little side step here. You don't have to write this down, because I want you to just watch. Just listen. Let's say that I give you a recipe. I don't know how to spell recipe. Is that right?
Yes.
Okay, don't look right. Looks like recite. All right. Recipe for 24 cookies. And that recipe is 1 cup of flour, 2 cups of sugar, 4 eggs, 2 cups of peanut butter, and 1 cup of milk. And there's some other items, but this is just the main items. Okay? And that makes 24 cookies. Well, what if I asked you that I want to make 48 cookies? What would you do? How do you know to double? It's double quantity, but basically, what does double mean? Times what? 2. Well, how'd you get the 2? You take 48 and divide it by what? 48 divided by 24 is equal to 2, and that's where you get the double. So if I asked you to make 72 cookies, what would you do? You triple it. But what if I asked you to make 56? Well, remember, this is the number desired over the number it makes. So you would put 57 over what? 24. Somebody give me that number. 2 point what? What? 2.375. This is called a multiplier. I could also write it like that. So if I have a odds against, I just take that and multiply it by the number that's bet. A lot of people don't know that. So you've got a 17 to 15. So whatever you bet, you multiply by 17 over 15. Just like you did right here. You basically multiply, to get 48 cookies, you multiply by 48 over 24. To get 57 cookies, you multiply by 57 over 24. So your odds against is going to be whatever you bet times 17 over 50. It's the same concept. Now, this question right here, you might as well ignore it. When you bet that the outcome is even number, the payoff is 1 to 1. How much profit? Now, I've got a problem with the way they word profit on this question. I don't like the way they use the word profit because we'll see in a minute why. Do you make, if you bet $19 and win? Well, you win $19. 1 to 1, you get the same answer. So that, nobody should miss C. Nobody. Well, see, that's why I don't agree with that. I don't agree with the wording. I take it up with the author because I've written emails and he still doesn't change it. So evidently he knows more than I do. Okay, so C is always going to be the same amount that you bet because it's 1 to 1. Always remember that on this question because this is a test question and it's going to ask you that C and all you do is type in the same number. Now here's where I really disagree with the wording. It says how much profit should you make on a $19 bet if you use our odds. Our odds is 17 to 15. So you take your handy dandy virtual calculator that you carry around in your pocket and you say 17 over 15, parentheses 17 divided by 15 and multiply it by what? A $19 bet. Now, how much profit do you make? I say the profit is $2.53. Why? You bet $19. That $19 is yours. All right? You give it to the bank. You bet. They give you back the $19, and whatever you made over that is what I consider what? Profit, but not him. He says the answer is, what was my answer? Hold on. $21.53. He says that the profit is $21.53. So you need to make that note. You need to highlight that. You need to write this down in your notebook, and you need to put a note and highlight it. Write the whole amount, $21.53. It's not $2.53, it's $21.53. What it should say is what is the payoff, not the profit. The payoff is what the bank is paying you back. Now, what kind of bet, what kind of odds do they have at the racetrack, at the horse track? 50 to 1, 200 to 1. So what does that mean? Well, if you bet $50 on a 200 to 1, let's see what you get. At the racetrack, if you bet $50 on a horse called I Suck, okay, and I Suck have 200 to 1, 200 divided by 1 is 200, and you bet $50 on I Suck, then you take home how much? The payoff is $10,000. Now what would have to happen for I Suck to win the race? The first 5 or 6 horses would have to get shot by a sniper. Okay? But there is a chance for that horse to win. You know, there has been cases where horses just go crazy and win a race, and everybody's like, "Who is that? What horse won?" You know, because animals are unpredictable. But that's what your bets are. So if you go, to a racetrack and you're betting on a horse, it's 2-1, and you know that horse is probably going to win. But if you bet on a horse that's 300-1, you know it's probably a zebra. You ever seen that movie? That's a cute movie, even though I know it's unreal, but it's a cute movie. What's it called? Stripes? Racing Stripes. It's a cute movie. All right, so do one more. Sorry. Do one more, and hopefully this one is the same. Why is it doing the same? Okay. Okay, let's see if I can get another one to come up, just so you have 2 in your notebook for the test. I'm trying to hurry. Huh? Yeah, but I don't want that part to be different. I want the roulette table to be different. Because that's what's going to change on the test. There we go. Alright, try that one. And if you can't get this one right, then you're pretty much a failure. Blow it up just a little bit down, please. There we go. Bring it down, please. Let's see, 38. Half of 38 is what, 19? So success, probability of success, or what is it, even, is equal to 19 over 38. Probability of not even, 40 minus 19. Wait a minute, that should be 40. That should be 40. There we go. And what is the probability of not even? 21 over 40. Okay, and that'll be that part. 19 over 41. And then the odds against would be 21 over 40. divided by 19 over 40, multiplied by 40 over 19, and 21 to 19 is your odds against. So the first one is 19 over 40. And this is 21 to 19. And the last one is the same. How much money? 19. And then what's the last one? 19 times 21 over 19. What does that come out to be? How much? 21 even? Wow. And that's it. You get to roll. I know some of y'all chomping at the bit. I forget what time class is over, so I'm sorry. Am I over? 2 minutes? Okay, good. I'm not over. Somebody cut my button off for me, please. Today's Wednesday. And Bailey. Is that here? Bolt.
Yeah.
Miss Clayton, I saw her come in. There she is. Cowart. I see Miss Cowart. Dutchke's here. Escobar.
Here.
Farr. No Farr. Freeman. Hammett. Harris.
Here.
Harvey. No Harvey. Hayes.
Here.
Johnson.
Here.
Mullins.
Here.
Murray's here. Newton. Poor. No Poor. Perdisi. And the three Robinsons are here. And Miss Scarborough is not here. Schuler. Simpkins. No Simpkins. Dennis is here. Smallwood. The Bones are here. Williams and Wood. All right, y'all have a good day. We'll go into 4.7 next.